Hello everyone, good afternoon. Great to see you here. I'm Michael Dubinsky. I lead the product management team for Microsoft Advanced Threat Analytics. And today we'll talk about ATA, obviously. But before that, we'll actually talk about how cyber attacks take place today, how APTs actually look. What is ATA and how it works? By the way, how many of you, by a show of hands, know ATA, have ATA, know how ATA works in general? Okay, so it's a pretty good topic to discuss. The interesting part, we have a live end-to-end APT demo, Advanced Persistent Threat, where we're actually going to attack an environment live with Mimikatz, with reconnaissance tools, with ATA deployed in the environment, and we'll see live detections. We have also some interesting discussions about how can you mitigate some of those threats with features available in Windows 10, Windows 2016. That would be kind of interactive. I have some swag, some ATA t-shirts, so if you want to answer those questions, you'll need to come closer because we won't be able to throw them that far away. And we'll recap. So first thing first, enterprise mobility and security, Microsoft vision, and that's where ATA is. Basically, Microsoft's approach to security is by looking at compromised credentials, compromised identities, and in general, taking the identity-driven security approach. Because in today's world, when I'm thinking about it, today at Microsoft, I can actually access the HR portal through, which is located on the cloud from my home, right? So I don't have any firewalls, I don't have any proxies, I don't have anything. How do I authenticate? What's my boundary? That's my identity, right? I use the username, I use the password, I actually get multi-factor authentication through my phone, and then I can gain access to that. So that's the identity-driven security approach. ATA is part of it, and its goal is to detect advanced attacks which are targeting our identities, and that's most of the advanced attacks. And obviously, in enterprise mobility and security, we have other assets like device management, application security, and data security. With that said, let's start with the attack kill chain. So the attack kill chain starts from the external reconnaissance phase. Basically, the attackers are looking at the different assets the organization have which are publicly facing. The VPN servers, proxy servers, whatever they can use for their benefit. Once they understand that, they infiltrate the environment. Now, they infiltrate the environment either by compromising one of the endpoints, maybe phishing attack, maybe a malware they managed to drop somewhere, or they manage to gain access to the network through the VPN or proxy or whatever other devices available on the internet. Now, once the attacker is inside the network, then the attacker begins the internal reconnaissance phase. Now, the internal reconnaissance, think about it. You just landed in a completely new environment. You have absolutely no idea how the environment looks like. What are the names of the servers? What IP addresses are being used? What are the operating system? Are the clients running Windows devices, Mac devices? What servers does the environment have? Is there an Active Directory? Is there an Exchange server? Is there a SharePoint server? What kind of VPN solution? So all those questions are questions attackers are trying to understand and eventually map the environment in order to figure out their attack vector. Now, their main goal at this stage is to gain access to domain admin creds, to privileged accounts. So the attackers are actually doing that through the slow privilege lateral movement cycle. They're moving from one device to the other in order to eventually gain access to some privileged credentials. Now, the goal of the attackers they want to access those privileged credentials is because eventually they want to get to this place of domain persistence or domain dominance. Why? Well, two reasons. One, if my entire campaign is based on a single set of credentials, what happens when those credentials are changed? What happens when this user account is disabled? That's it. My campaign is over. Now, the attacker spent a lot of time, a lot of money getting to that specific point. So they want to make sure their campaign is successful, even if that single set of credentials has been changed or disabled or not in use anymore. That's for the first part. Now, once the attackers got to this domain persistence phase, and they got this by either installing something on the domain controller, maybe a piece of malware, maybe they managed to copy the entire Active Directory database, maybe they have what we call a golden ticket attack, so they have a very, very secret hash that the domain controllers use to encrypt the Kerberos tickets. All those are examples of domain dominance attacks. From that point, we're done with the general IT purpose attacker, and we're moving to the subject matter expert. And that's something we actually see in real attacks at our customers and at Microsoft based on the Threat Intelligence Center that is constantly monitoring the attacks that are happening on the different environments. So the second part, the high privilege lateral movement cycle, is basically where we have this subject matter expert. Could be if we're attacking a financial organization, so it could be someone that worked for financial organizations that knows how the network is built and how the mainframe is working. If we're attacking a pharmaceutical company, it could be someone that knows the actual chemistry of the formulas and can understand and differentiate between a formula for the next drug for cancer and between a formula for the next drug against headache, right? Those are not on the same level of interest for the attackers. So that's the high privilege lateral movement cycle, where the attackers are actually accessing a bunch of different resources, trying to understand where is the data that they want to use. Where are the credit cards? Where is the pharmaceuticals? Where are the documents with the sensitive information? Where is the source code, the intellectual property of that company? It takes some time. Once they've done that, the next part is to exfiltrate that information. So again, if we're talking about financial organizations, each credit card, each stolen credit card costs between $5 to $15 on the dark web. So if I'm an attacker and attacking a financial organization, my goal would be to get as much credit cards as possible and sell those on the dark web. That's my goal as the attacker. I want to get some money for what I'm doing. So the exfiltration phase is basically taking the data that the attacker managed to find and managed to access and exfiltrating that data to a location where the attacker can access that data freely. It could be a Dropbox account, it could be just a storage account somewhere on one of the cloud providers, it could be an FTP server owned by the attacker. All of those are valid examples of exfiltration. Once that is done, then the attacker's mission is complete. Now, our goal with ATA is actually to detect those security attacks and insider threats before they cause damage, early in the kill chain, as early as possible. Now, the way we're doing that is by combining two types of detections. The behavior analytics, which is basically building statistical models and learning how the users, how the entities, the devices, the resources behave in the organization, inside the organizational network. So if we're talking about users' behavior, it's learning which devices the users are working from, which resources do they normally access, what are the normal working hours, that kind of information. And once we've learned that information, detect anomalies and deviations from the normal behavior. So just as an example, I'm usually working from more or less 3 devices, so that would be my laptop, my phone, and my tablet, right? Now, if all of a sudden, my credentials are being used at dozens or hundreds of different devices inside the corporate environment, that could actually point to a lateral movement where someone compromised my credentials and using those credentials at a bunch of different devices. So that's something we can detect using the behavior analytics. The second part is the detection of advanced attacks and security risks. So for that, we actually have a security research team that is constantly looking at the most advanced techniques the attackers are employing today in the advanced persistent threats they're executing. So just to give you an example, pass the ticket. How many of you have heard about that specific attack vector? Okay, so pass the ticket is a way for attackers to perform lateral movement. They steal a Kerberos ticket of my account from my laptop, and they use that Kerberos ticket on a bunch of other devices because that's their way of stealing my credentials. So that's a more sophisticated way or a more advanced way than pass the hash. Pass the hash based on NTLM hashes, pass the ticket based on Kerberos ticket. Very similar, different protocols. So with ATA, we can deterministically detect a pass the ticket. Why? Because we're building this relationship between Kerberos tickets, users, devices, and now we can know that a domain controller issued that specific Kerberos ticket to Michael Dubinsky on Michael's laptop. Now, if ATA sees that specific Kerberos ticket being used at a different device out of context, that's it, that's pass the ticket. We don't need a statistical model for detecting that. And that's one of the very strong differentiations we have with ATA from any other product out there. So basically, those two detection engines combined is what ATA brings to the table, and that's the advanced threat detection we're able to provide to our customers. Mapping that back to the kill chain, that's where ATA focuses on those big 2 parts in the middle. The first lateral movement cycle, the low privileged, where the attacker's goal is to gain access to the privileged account, domain admin account, and the second lateral movement cycle, which is basically the high privileged lateral movement cycle, where the attackers are looking for the assets they want to access. In terms of specific detection, so we have a lot of detection around every single phase of the attack kill chain. So if we're talking about the reconnaissance phase, we're detecting reconnaissance using multiple protocols, using DNS, using net session enumeration, and we'll see some of those in the demo today. Compromised credentials, so again, a combination of both statistical and behavior analytics, as well as deterministic detection. Lateral movement, past the hash, past the ticket, over past the hash. Those are all attacks we're seeing every day in the APTs that are being executed. All the APTs that are being executed are using one form or another of those attacks. And eventually, the domain dominance. So the domain dominance is basically the persistence of the attacker inside the victim's network. Specifically for domain dominance, we're looking at things like malware deployed on the domain controllers, golden ticket, which is basically a Kerberos ticket the attackers build by themselves, and they can tell the domain controller whatever they want to be or whoever they want to be. Things like remote execution against the domain controllers, replication requests, all those are methods of domain dominance. And that's what we have today. You can download ATA release 1.7, and those are the detections you will get. Every release, we're adding new detections in every single part of that specific of the kill chain, both behavior-based detection as well as deterministic detections. So, a quick overview about how ATA works. What are the different components? So the ATA deployment consists of two main components: the ATA gateway and the ATA center. The ATA gateway is basically the sensor. It's completely stateless. Its goal in life is to see the data, to analyze the data. The data that it's actually able to analyze is raw network traffic going in and out of the domain controllers, raw network traffic going in and out of the DNS servers, logs collected either via Windows Event Forwarding or via syslog forwarder from your SIEM solution to the ATA gateway. So that's the data sources, the three data sources that ATA supports today. Once ATA analyzes that specific information, it also enriches the data. So just for example, if we're talking about network traffic, in the network traffic we have the username and we have the IP address. ATA takes that username and actually resolves that to the user object in Active Directory. Why? Because we want to understand the organizational context. We want to understand that user's group membership. We want to understand that user's manager. We want to understand that user's organizational hierarchy. All that information is available to ATA inside the Active Directory. So that's one of the goals the ATA gateway is doing. And once the ATA gateway have enriched that specific information, then the gateway takes this enriched logical network activity or logical event activity and sends it to the ATA center. Now, for the gateway, we have two flavors. We have the regular gateway and the lightweight gateway. The regular gateway is a standalone server which you deploy using port mirroring. So you need to configure span ports either on your physical switch or the virtual switch. The lightweight gateway is a version you can deploy directly on the domain controller. It basically deploys a Windows service that runs on the domain controller. And in that case, you don't need to configure span ports, you don't need additional hardware. Now, the difference between the gateway and the lightweight gateway is, first of all, resource limitation. We never want to hit the domain controller performance. So we have this dynamic resource limitation where we're constantly looking at the CPU and memory of the domain controller activity, basically the LSAS process on the domain controller, and we limit the ATA gateway based on the current CPU and memory consumption of LSAS. So worst case scenario, if the domain controller authentication service spikes, the ATA gateway will limit its own CPU and memory, and worst case, it will drop network traffic or even shut itself down, but it will never affect the domain controller performance. We actually designed the lightweight gateway with that specific goal in mind. So that's the gateways and the two gateway flavors. Now, the ATA center, it basically gets the information from all the gateways in the environment. So basically, every ATA gateway can support one or more domain controllers. Obviously, the lightweight gateway can be deployed only on one domain controller. The ATA center can support multiple gateways from multiple domains in the same forest. The ATA center basically gets the information from all the gateways and analyzes that information in real time. So it's very close to stream analytics. So every single network activity or event activity being fired at the ATA center being analyzed in real time. The detectors are being run against each relevant network activity. And the specific activities are being stored in the database. The other things the ATA center performs, it also performs central configuration management for all the gateways. It performs central update point for all the gateways. And it provides the web management interface for the ATA console. So basically, looking at the suspicious activities, investigating the suspicious activities, changing the ATA configuration, that's all available in the ATA center. So those are the two main components of ATA. In terms of the main features, so one is the automatic updates. ATA is actually integrated with the Microsoft Update platform. So every time we release a new version of ATA, it automatically gets downloaded, if you opt in, obviously, to the ATA center, gets deployed on the ATA center, and when it's deployed on the ATA center, all the gateways are pulling the new version automatically and updating themselves. So that's a very important feature because now the update process is seamless. The second thing is integration with SIEM solutions. We have two-way integration with SIEM. We can get information from SIEM solutions, so basically events that we're collecting could be collected either via Windows Event Forwarding or via integration with the leading SIEM solutions, syslog forwarding basically from the SIEM to ATA gateway. And the other way around. Every time ATA detects a suspicious activity, it would actually send a notification to your SIEM using the syslog protocol, and ATA can also send a notification using email. So that's the main points of SIEM integration. And the last thing is the deployment. So for ATA deployment, it takes, and you'll be able to see that tomorrow at Benny and Hayden's session, it takes anywhere between 5 to 20 minutes to actually deploy the ATA center and then deploy a couple of gateways. Very simple deployment. Every time we design new features, we design that with simplicity in deployment and management in mind. So that's about ATA. Now our story begins, and we'll start the demos in a couple of minutes. Let's introduce our attacker. Our attacker, Jay Hackersby, senior security researcher, Kerberos expert, no longer Batman, but he hacks corporates for fun. The environment, we have Jeff the victim, we have Ron the help desk guy, and we have the all-powerful NUC Chorus. In the environment, obviously, we have a domain controller and the ATA center. Starting point, spear phishing. The attacker did some external reconnaissance. He knows Jeff the victim is a finance person that is constantly getting Excel spreadsheet from external vendors. So they said to themselves, it makes sense to send an Excel spreadsheet with malware in them, or maybe a 0-day, or whatever the case is, to Jeff the victim, which opens a backdoor on Jeff the victim's device. Now, the attacker's goal, or our goal, because we're going to be the attacker in a second, is to get from Jeff victim's device to the domain controller to get full domain dominance and get control over the domain controller. Make sense? Let's go. First step, reconnaissance. So we landed in the environment. Landed in the environment, absolutely no idea how the environment looks like. So what we need to do is, let me just, okay. What we need to do is basically understand how the environment looks like. For that, we have several scripts. I will show you those. First part, super easy. reconnaissance using the net user and net group commands. Not very complicated, right? Pretty standard IT admin tools. What kind of information would that give me? Very useful if I'm the attacker. And all I need to be is just a regular authenticated user to actually execute those commands. So let's do that. So I can see in the domain admins group, we have administrator, we have Michael, and we have Nocturis. That's pretty useful information. I have all the information about the other groups. I have all the groups in the domain. I have all the users in the domain. And actually, we can already see in the background that ATA has detected the reconnaissance using directory services enumeration. And specifically for that scenario, we're actually asking you for input to provide us information because in certain cases, security scanning tools are performing that specific operation. So we're providing you with the ability to provide input to ATA's detection logic. So for future detections, we won't detect that if it is a benign reconnaissance by a security scanner. So that was detection number one. Very useful. Remember, we now know that Nocturis is a domain admin. Second reconnaissance. NetSys, publicly available tool. All I need to be is an authenticated user to run that specific tool. What it will do, it will enumerate all the open SMB sessions against a specific SMB server. In that case, I'm going to run that against the domain controller. Now, why is that useful? Well, because every single user has an SMB session against the domain controller when it processes group policy. So by running that specific tool against the domain controller, what I will get is all open SMB sessions that currently exist in the environment. So now we know that Jeff victim is logged in on that specific IP address, .3, and now we also know Nocturis is logged in on that specific device, .11.6. So as the attacker, I now have my attack vector, right? So that's the first part. Let's switch back to the presentation to understand what exactly happened. First of all, that's what we know so far. We've compromised Jeff the victim's device. We have Jeff the victim's credentials. And we know Nocturis is logged in on the admin PC. Specifically, we know the IP address. My resolution from IP address to device name would be very easy using DNS reverse lookup. So I didn't even go through that stage. So that's what we know. What did we do? Collected user and group information using the SAM remote protocol and figured out our attack vector using the net session enumeration. Pretty useful stuff. Question for an ATA t-shirt. How can you protect against any of these attacks? The person, well, you'll be next. Yes. Not really. I haven't really dumped any credentials. Upgrade to Windows Server 2016 and? And? Close enough. So Windows 10 anniversary update actually introduced an option to disable the SAM remote protocol. And Windows 2016 Server actually enabled the configuration of ACLs for performing the SAM remote protocol queries. So any of these two will block the attacker from executing the first attack, the SAM reconnaissance. It wouldn't block, though, the attacker from executing the net session enumeration. Great. Let's keep on going. First part of the lateral movement cycle. But before that, Kerberos 101. How many of you are familiar with the Kerberos protocol? Okay. Very quickly, the user puts in their username and password. The password gets translated using one-way hashing into a key. That key is being used to authenticate against the domain controller. That's basically the authentication service request. If the key matches the key that the domain controller has in its own database, then the domain controller replies in authentication service reply, providing that little red thingy called TGT. TGT, ticket granting ticket, think about it as your social security card. That's the card that every time you're going to the different government offices, you're using the same card in order to get access to the different services. So if you want to get a driver's license, you're coming with your social, at least in Israel, you're coming with your social security card, you're getting the driver's license. You want to get a passport, you're coming with a social security card, you're getting a passport. So that's the TGT. Next part, the TGS request. I'm taking my social security card, I'm going to the government saying, hey, I want to travel abroad, can you give me a passport? The government verifies myself and says, yes, here's your passport. That's the yellow thing, the TGS, ticket granting service. Now I'm taking my passport, and when I'm flying out of the country, I'm giving that to the passport control. So that would be my server. So every time I access a specific service, I take the ticket granting service, I provide that to that specific server, the server authenticates me, so the passport control actually verifies I can leave the country, I don't have any issues outstanding against me, and then lets me do whatever I need to do. Make sense? By show of hands, does it make sense? Okay, great. We actually had an argument, would that analogy work or not? It did. Thank you. So, let's go back to the demo environment. By the way, in the meantime, ATA has also detected the reconnaissance using SMB session enumeration. So now we know that the attacker from victim PC actually enumerated the SMB sessions, and they know about Nocturus. So from the defender side, we have that specific detection. We already can stop the attack very early in the attack kill chain, already at the reconnaissance phase. But let's keep on going. So our next goal is to gain access to other assets. By saying other assets, I actually mean I want to gain access to the admin PC. So my first part would be to see what credentials I have. So for that specific example, I'm going to use Mimikatz and dump all the available credentials on the device of Jeff the victim. Specifically for this demo, I'm going to output that into a text file called letmove number 1. So let's do that. Okay, that's done. Let's open our text file. And let's search for usernames in the text file. Username number 1, Jeff the victim. I don't care about it. I already have all the credentials I need. Username number 2, still Jeff the victim. Let's go. Let me zoom out for a second so we can see. Next set of credentials, the actual computer account of the victim PC. So in this specific example, not super interesting. In other examples, sometimes people tend to forget the computer accounts can actually have permissions and authenticate. If I was the attackers, I can actually steal the credentials of the computer account, and if that computer account has some excessive privileges in my environment, I can use that as easy as I'm using a user account. But again, not in our example, so let's keep on going. And what we discover while looking at the file is that we have the credentials of this guy, Ron HD. Sounds interesting. I wonder who he is. How can I find out? We already did that. Net user for Ron HD against the domain. So looking at that, I see all the information about Ron HD. I see he's a member of the help desk group or whatever. So now I'm thinking, as the attacker, maybe Ron HD has local administrative privileges at other devices in my environment. Let's figure out. For that, I'm going to use a tool called Metasploit which provides that very interesting PowerShell commandlet. Get local groups, which I can execute against the different devices in my environment. So now, I own Jeff the victim's device. I'm thinking I have the help desk guy's account. Let's see if that help desk guy is a local admin on the admin PC. And I see that members of the administrator on the admin PC are that specific SID, and eventually that specific SID, which translates to RonHD. So now I know that I have the credentials of RonHD. I have either the Kerberos tickets or the NTLM hashes I can use in order to access the administrative device. Let's do that. Let's steal Ron's credentials. In this example, I want to use Ron's NTLM hash. Here it is. And perform an attack called overpass the hash, which basically means I want to take the NTLM hash and create a Kerberos ticket out of it. So basically, I can do the authentication service request, the AS request we saw in the Kerberos example, using that specific NTLM hash. So I have the hash. This is how I'm actually doing overpass the hash. Again, using Mimikatz, I'm saying all I want to do is pass the hash for that specific user. Here's the NTLM hash in my specific domain. So executing that will open another command prompt with which I can now dir into the admin PC $share. Hopefully, and I did. Looking at the Kerberos tickets, I actually have a Kerberos ticket for RonHD, both a TGT and a TGS for the admin PC. Again, let's stop for a second and discuss what just happened. First of all, in infographics. Now, I owned Ron the help desk guy, and now I also own all access to the admin PC workstation. I'm this close to Nacchoris's account. That's my goal. That's where I'm going after, right? Remember, the net session reconnaissance, I figured out I have Nacchoris logged in on the .6 IP address. I'm already there. I already have local admin access to the admin PC. How did I do that? Using overpass the hash. So I stole the NTLM hash of Ron the help desk guy. I did some additional reconnaissance using tools we already know, or using methods we already know. And using the specific NTLM hash, I managed to create a Kerberos ticket with which I access the admin PC. Bonus question for an ATA t-shirt. How can you protect? Yes. Credential guard. Credential guard would help, yes. Any other options? First of all, well done. Any other options? Yep. We can block NTLM, but I didn't use an NTLM. I used an NTLM hash to create a Kerberos ticket. So for that specific scenario, in general, blocking NTLM is a good idea. You should do it. It will mitigate past the hash attacks. It wouldn't mitigate overpass the hash attacks. Last attempt? On the client firewalls, I can block connections from other clients in the environment. That's also correct. So all those are correct answer. First of all, that's for you, Hayden. Need your help? Thank you. The idea I had in mind is actually disable low-level encryption types. So by design, when using an overpass the hash attack, the encryption type for the Kerberos ticket would be RC4, which is a pretty low-level encryption type. If all we have in the environments are Windows 7 and later clients, and Windows 7 or Windows 2008 R2 and later servers, I don't need to use the low-level encryption types, and I actually have a group policy setting. I can disable the low-level encryption and enforce the entire environment to use only AES encryption types. So that's something I can do tomorrow. A suggestion, don't do that tomorrow, because we know there is a lot of down-level clients. Even like if you have Java installed on your endpoints, they sometimes, old versions of Java have their own implementation of Kerberos, and they use down-level encryption types. So test it, but in general, that will mitigate overpass the hash attack, in essence. So that's our overpass the hash attack. Next part. Now I actually want to get Nocturis's credentials. So for that specific attack, again, let's go back to our environment. So in the meantime, with ATA, we've detected encryption downgrade activity. So again, as I mentioned, the essence of the attack, we'll learn what encryption types are being used in the environment. If we know the users, the device, the domain controllers, everything are normally working with high-level encryption types, there is absolutely no reason for someone to be using RC4 encryption or down-level encryption. So we detected that with the mention saying potential overpass the hash, and we're providing you the information about the user, about the device, about the domain controller. All that information is available in the ATA console. And we've also detected unusual protocol implementation. So in a lot of scenarios, attackers are using their own stack for implementing authentication protocols such as Kerberos, NTLM, SMB. So in this specific example, we detected that single attack using two detection methods, both the unusual protocol implementation as well as the encryption type downgrade. Okay, so far so good. The demo is working. I'm happy. Let's keep on going. So now our next part, we're going to do the second part of the lateral movement, where I want to steal the ticket of Nocturis. Again, in this example, I'm going to do a pass the ticket attack. So I'm going to use psexec to actually execute against the admin PC, dump all the Kerberos tickets on the admin PC, and copy those locally back to my device. That's the actual command line that I'll be using. Again, using Mimikatz to dump all the Kerberos tickets and closed in a psexec command, and eventually copying that information. Now, obviously, I'm going to do that from the command prompt where I have run HD's Kerberos tickets. So again, we're building our attack. We did overpass the hash. Now we're doing pass the ticket from the same command console. Let's execute that. Starting psexec service. Okay, we dumped all the Kerberos tickets, exited Mimikatz, copied all those Kerberos tickets locally to my device, temp, tickets, here they are. So all the Kerberos tickets that were available on the admin PC device are now available to me, the attacker, on the victim device where I first landed with the Excel with the malware. So now I have all those Kerberos tickets. Specifically, in this example, I probably want to use the TGT because I want to gain access to as much resources as possible. So I'm going to do that. Just copy the file name. Paste that. Into the script where we actually import the Kerberos ticket. And imported the Kerberos ticket. Now I can see I have Nocturis's Kerberos ticket in my logon session. So again, as the attacker, now I have the domain admin privilege. How can I prove that? Easy. Let's steer into the domain controller. Done. I'm a domain admin. That's it. So for the first part of the advanced attack, again, let's go to the slide deck, figure out what just happened. Infographics-wise, I have NAC account. That's it. I'm a domain admin. What do I want to do next? We'll talk about it. But before that, how can you protect? So you already answered that question. For that specific scenario, Credential Guard is my choice. Dumping Kerberos tickets using Credential Guard is not something that is possible, at least the TGT. So if I had Credential Guard enabled on the administrative device, I won't be able to perform that specific attack. I'll leave some time for Q&A in the end. How can you protect? Enable Credential Guard. So next part, domain dominance. Again, looking here at the ATA console, ATA successfully detected passed the ticket attack, and we actually provide you with the information that NAC Choris's ticket was stolen from admin PC and used on the victim PC to access those two resources. So again, we're already at later stages of the attack kill chain. Our severity is pretty high. It's pretty dangerous right now. ATA is there to tell you that it detected that information. Up to you how you need to mitigate that. We'll discuss that at a different session probably. So my next goal is to create something called the golden ticket. A golden ticket is basically a TGT the attacker has created offline and is available for use in the environment. Now, that specific scenario is available by using the Kerb TGT account hash, and that means the attacker can create a Kerberos ticket, inject any kind of user membership, group membership, whatever they want. They can impersonate anyone, encrypt that with the key the domain controller trusts, and use that in the environment. That's the domain dominance. That's what I want to do. So again, very easy command line. Now that I'm a domain admin, I can just dump all the hashes for the Kerb TGT account using the dcsync command. Done. Here are all the hashes. Here's the NTLM hash of the Kerb TGT. That's all I need to create a golden ticket. So the next part would be actually creating a golden ticket. But before that, where are we in the kill chain? Now we have the domain dominance. So now I can create Kerberos tickets offline and use them in order to access every single resource I have in the organization. What did we do? We used domain control replication mechanism to actually pull that information from the Active Directory domain controller. So nothing except a normal replication request would be logged anywhere. How can you protect? Bonus question. Yep. Yes, still haven't gotten there, but first of all, you do deserve, a shirt. But specifically for stealing that kind of information, the only thing I can do right now is detect. Using that information, yes, I might be able to do what you just mentioned, reset the KRB TGT account twice. But we'll discuss that in a second. So today, protecting, not yet. You can give someone the t-shirt if they want. Who wants an ATA t-shirt? Okay, done. Thank you. So the next part is we actually want to use that specific Kerberos ticket. So again, let's move to our demo environment. First of all, ATA detected the malicious replication of directory services. So now we at least know we have something compromised. But now in order to use the Kerberos ticket, I'm going to create the golden ticket. Very simple command line. Use the Kerb TGT hash to create a golden ticket. Mimikatz by default will inject domain admin and enterprise admin security IDs into that specific ticket. So super easy, very short command line. Let's run that. Golden ticket created, saved into a file. Next part, importing the golden ticket into the actual environment. So same thing like we did with PTT, taking the golden ticket, importing that into my Kerberos session. So now I have this ticket as Natalie Nottingham, which is just a username I invented, or could be an existing username in the environment, could be a non-existing username in the environment. It doesn't matter, because the Kerberos ticket is an actual valid Kerberos ticket. Now, that specific Kerberos ticket is also a privileged Kerberos ticket. Not C4. Here we go. So Natalie Nottingham, she's not a domain admin, but I managed to access the $C share on the domain controller. So that means that specific Kerberos ticket belongs to a privileged account. Now, the next part, actually for performing resource access, I don't have dozens of resources in my environment. So just for the sake of the demo, I created a small PowerShell script that will request access to a bunch of resources. A couple of web servers, a couple of event logs at a couple of endpoints, some application servers, DCOM. So instead of doing the actual application request, opening the browser, accessing that website, I'm just doing the same thing, but using a script by asking the domain controller to give me access to those specific resources. So let's execute that. And look at my Kerberos tickets. So I have a bunch of Kerberos tickets for all those resources as Natalie Nottingham. Switching back to the environment, what did we do? The high privilege lateral movement cycle. We used the Kerberos ticket, and we used that specific Kerberos ticket to access a lot of resources as a highly privileged account. So imagine those were database servers. Imagine those were HR web servers. That specific user account, the attacker could inject any security ID into the Kerberos ticket in order to access those web servers, in order to access those databases, and steal and gain access to any information they wanted. How can you protect? So the gentleman over there, well, let's try it again. Yep. Bring a golden ticket into ATA. Right. So you're mentioning a honey token. So one option, we could actually create a kind of a honey token account for the attackers to use and to use that specific hash. But in general, I can actually reset the password for the Kerb TGT account. And the gentleman over there mentioned correctly, you need to do it twice. Why? Because domain controllers respect the previous hashes. So if I do it once, still the old hash would be respected. I could use the same Kerberos ticket. If I do it twice, all the old Kerberos tickets would be invalidated. Now, if you're doing that proactively, just don't do both times at the same minute, because it would invalidate all Kerberos tickets in the environment. So you could do that in a difference of a couple of days, and that way you'll be able to recycle the Kerb TGT account password every couple of days, weeks, months, depending up to your operational processes. So that's one of the methods to mitigate a golden ticket. Make sense? Going back to the ATA console, first of all, we've detected an encryption downgrade. So now we've detected a different flavor of encryption downgrade, because again, for that specific scenario, we know that when using a golden ticket, one of the techniques is to use one specific hash of the golden ticket. So we've detected an encryption downgrade that actually says the TGT that was being used by Natalie from victim PC is using a low-level encryption. This may be a result of a golden ticket in use. And the second thing is the abnormal behavior. So that's the machine learning detection that kicked in and said, hey, we have Natalie that usually works from 4 normal devices, and all of a sudden we saw Natalie working from the victim PC, and accessing 20 abnormal resources that we've never seen Natalie accessing before. So that's the statistical model that actually knows how Natalie behaves as usual. And now it detected the abnormal behavior for Natalie that doesn't comply with Natalie's normal behavior and the organizational normal behavior. So that's the ATA detections. Mapping that back to the kill chain, so we went through all the phases in the kill chain. We went from the internal reconnaissance phase using the some remote net session enumeration. We did the low privilege lateral movement cycle using Ron Helpdesk's account in order to access the admin PC. We dumped Nocturus's credentials and got the domain admin creds. Dumped the KERP-TGT to create a golden ticket for the domain persistence, and then used the golden ticket in the high privilege lateral movement cycle in order to access the assets I actually wanted to access. So that's our attack summary. Recap. Attackers leverage a huge blind spot inside the network. We're very good at protecting the perimeters with firewalls, proxies, VPNs, whatever. But once the attackers are inside the network, we're not very good at finding them. Second thing, the attackers actually use traditional IT tools, things like NetUser, NetGroup, net session enumeration. All those are benign APIs, benign tools that are okay for use. But the problem is that the attackers are using them in malicious way. So by detecting behavioral anomalies, we can actually detect intent. We can learn what's normal, and we can learn what's abnormal and alert on the abnormal activities. That's exactly what ATA does. And eventually, defenders should learn, first of all, how attackers behave because the behavior constantly changes, mitigate using the mitigations possible, always detect as much as possible using ATA, using endpoint security solution, using cloud application security solutions. And eventually, just one last thing, John Lambert, who leads our Threat Intelligence Center, said, you're never stopping attacks. You're increasing attackers' requirements. Consider counter-move and circumvention as a work factor. That's something I think all of us should remember. So thank you very much. We'd be happy to get your evaluations. Interesting session tomorrow, how to deploy Windows Advanced Threat Analytics. Benny and Hayden will deliver that. It's on Thursday, I'm sorry, not tomorrow. And some resources to get you going. Thank you very much.